This is a video from a Calculus 1 class. The directions say to differentiate. Let's take a look at problem number 1. Suppose I'm given f of x is equal to 3 sine of x minus 2 cosine of x. And I want to find f prime of x. Well, I know that the derivative of sine of x is equal to cosine x. The derivative of cosine x is equal to negative sine of x. And so putting this all together, I get 3, and then I'm going to multiply by the derivative of sine x, which is cosine x. I'm going to go minus 2 times the derivative of cosine x, which is negative sine of x. And if we go one step further, we can say f prime of x is equal to 3 cosine x plus 2 sine of x. That's how we do problem 1. Let's take a look at problem number 5. And these problems are from section 3.3 in the Stewart Calculus textbook. Suppose h of theta is equal to theta squared times sine of theta. And I want h prime of theta. This involves the product rule. So I'm going to write down the first function, which is theta squared. And I'm going to multiply this by the derivative of the second function, which is cosine theta. Okay? So this is the first function times the derivative of the second function. I'm going to go plus. Then I write the second function, sine theta, right? And then I multiply by the derivative of the first function, which is 2 theta. So I label it like that. Now, notice how each term has a theta in common. And so I'm going to pull that out. And when I pull out a theta, I'm going to take theta and multiply by theta cosine theta plus 2 sine of theta. And again, this is equal to h prime of theta. That's how we do problem 5. Let's take a look at problem number 9. So on problem 9, we have f of theta is theta minus cosine theta times sine of theta. And so this involves, again, the product rule. So if I take f prime of theta, I'm going to write down the first function, which is theta minus cosine theta. I'm going to multiply by the derivative of the second function, which is cosine theta. Then I'm going to go plus. I'm going to write down sine of theta. That's the second function. And I'm going to multiply by the derivative of the first function. Now, the derivative of theta with respect to theta is 1. The derivative of cosine theta with respect to theta is negative sine theta. So I'm going to get minus negative sine of theta. Okay. Now we have to do a little bit of simplifying here. So if I distribute the cosine theta in, I get theta cosine theta minus cosine squared theta, right? plus sine theta times, when you subtract a negative, you add. So you get times 1 plus sine theta. And I'm going to go one step further. Now we get theta cosine theta minus cosine squared theta plus sine theta plus sine squared theta. And again, this whole thing is equal to f prime of theta. That's how we do number 9. Let's take a look at problem number 13. So if we have f of theta is sine theta divided by 1 plus cosine theta. Now, this is a classic problem that involves the quotient rule. So we have the high over low, right? So if I want f prime of theta, I'm going to take low, which is 1 plus cosine theta. That's the low function. I'm going to multiply by the derivative of high. The derivative of sine theta is cosine theta. Then I'm going to go minus, and then I'm going to write sine of theta times the derivative of low, which is negative sine theta, right? Because the derivative of a constant is 0. The derivative of cosine theta is negative sine theta. I'm going to take that whole thing and divide by 1 plus cosine theta raised to the second. Now we're definitely going to go a few steps on here. So if I distribute the cosine theta in, I get cosine theta plus cosine squared theta, okay? Now, a negative times a negative is a positive. So this is plus sine squared theta. And I'm going to divide by 1 plus cosine theta raised to the second. But we're not done, because we have to look at these last two terms and recognize that cosine squared theta plus sine squared theta is equal to 1, okay? So this is cosine theta plus 1 divided by 1 plus cosine theta. If you don't mind, I'm going to write this times 1 plus cosine theta on purpose. Now, I need you to view cosine theta plus 1 as a factor. And to get you to do that, I'm going to put cosine theta in parentheses, and I'm going to put a times 1 here. Because what we can do from there is we can cancel the 1 plus cosine thetas accordingly. And when it's all said and done, we can say f prime of theta is equal to 1 over 1 plus cosine theta. And I would want you to get down to here, ideally. And let's do one more for this video. We'll call this problem 17. And on problem 17, we have f of w is 1 plus secant w divided by 1 minus secant w. And I want f prime of w. Well, I'm going to take the low function, which is 1 minus secant w. I'm going to multiply by the derivative of the top function, which is secant w times tangent w. I'm going to go minus. then I'm going to write the top function, which is 1 plus secant w, times the derivative of the bottom function, which is negative secant w tangent w. And here, we're going to make a little bit more room here so we can all read this. So we're going to call this f prime of w. So I'm going to go 1 minus secant w times secant w tangent w minus the top function, which is 1 plus secant w times the derivative of the bottom function, which is negative secant w tangent w. And I'm going to divide by 1 minus secant w raised to the second. Now, a negative times a negative is a positive, okay? The denominator doesn't change. It's still 1 minus secant w squared. On the top, we get 1 minus secant w times secant w tangent w, okay? But a negative times a negative is a positive. So I'm going to go plus 1 plus secant w times secant w tangent w. Okay, just like this. But notice how we have a secant w, tangent w in common. So I'm going to pull that out. Now, when I pull that out, I get the following. So I'm going to get secant w times tangent w times the quantity. Now, I get 1 minus secant w, this piece right here, plus 1 plus secant w. And then we're still dividing by 1 minus secant w raised to the second. And then notice how the secant w's can cancel. 1 plus 1 is 2. So f prime of w is 2 secant w tangent w, all divided by 1 minus secant w raised to the second. And that's a good stopping point for this video. This is a video from section 3.3, and we looked at problems 1, 5, 9, 13, and 17. Thank you.